In this question from the chapter matrices, we are given matrix A, B, and further it's given that x square is equal to -1. We need to show that A plus B whole square is same as A square plus B square. So first thing that we will do is to obtain what is A plus B. So clearly A plus B will be the sum of these two matrices, that is A plus B is equal to, we know that matrix addition is adding their corresponding elements. So that is 0 plus 0 is 0. So we are getting A plus B as 0 plus 0 is 0. Minus x plus 1 is minus x plus 1. X plus 1 and it's 2 by 2 is, that is 0 plus 0 is 0. So we got A plus B. Now we have to calculate A plus B whole square. So you should know that A plus B whole square is A plus B into A plus B. That means we'll be multiplying A plus B with A plus B. So what is A plus B here? A plus B is this matrix. So it is multiplied with itself. This is x plus 1 and 0. Now, if I find its product, it's if I do so, like the first thing that we do is first row multiplied by first column. So it's 0 into 0 and minus x plus 1 multiplied by x plus 1. So that will be, we can alternately also take this as 1 minus x, right? If I consider this to be 1 minus x. So this is 1 minus x multiplied by, say, 1 plus x. So this is actually 1 minus x square. So we'll get this entry as 1 minus x square. The next thing that we'll do is first row multiplied by the second column. So we'll get what? 0 multiplied by any number is 0. So this multiplied by 0 is again 0. So we'll get this as 0. Now finally, second row multiplied by the first column. So it's again 0 over here. That is 0 multiplied by any number is 0. And that added with this multiplied by this is again 0. Now continuing with the next, that is second row multiplied by the first column. So this multiplied by this is what? Again is same. That is 1 minus x square. So we got this as A plus B whole square. We got what is A plus B whole square. And as you can see in the RHS, we have to obtain A square and B square. So for that, let's say I make some space over here. Now in the next part, I'm obtaining A square. Clearly A square is what? A multiplied by A. So that is 0 minus x, x 0, that multiplied by 0 minus x, x and 0. So this is what we are getting A square. So first row multiplied by the first column, that is 0, and minus x into x is minus x square. Then if you continue multiplying the first row with the second column, we'll get this is 0 here. Second row multiplied by the first column is 0 and 0 again. And then second row multiplied by the second column is minus x square. Now, once we obtain A square, let's obtain B square. B square is the same way. That is B multiplied by B. B is 0, 1, 1, 0. That multiplied by 0, 1, 1, 0. So what we'll get B square as? This is 0. First row multiplied by the first column is 0. Sorry, this multiplied by this is 0 and 1 into 1 is 1. First row multiplied by the second column, this is 0. And second row multiplied by the first column is 0 and 0. That is 0 again. Second row multiplied by the second column is 1. Now, further, what we have to do is to obtain what is A square plus B square. So if I add these two, that is, if I add A square plus B square, that means adding this matrix with this one. So what you'll get here, that is, you'll get 1 minus. What I'm doing here is adding this with this. So this is 1 minus x square. This is 1 minus x square. 0 plus 0 is 0. Adding this with this is again 0. And finally, 1 minus x square. This was 0. And this is again 1 minus x square. Now it says that you can see here, replacing x squared with minus 1, what you'll get here. Replacing this x squared with minus 1, it is 1 minus minus 1, that is 1 plus 1, which is 2. So this is 2, 0, 0, 2. That is the LHS expansion. And over here, that is the a square plus b square. That is a square plus b square. What do we have here? Replacing again x square with minus 1, that is 1 minus minus 1 is plus. So that is 2, 0, 0, 2. So that is equal to the RHS. So we got the LHS is equal to RHS in this case.